All right, lesson 2 in Unit 6 is focusing on bisectors and triangles. You should know most of this vocabulary, but I'm going to go ahead and go over it again just to make sure. We're going to talk about two types of bisectors, perpendicular bisectors and angle bisectors. The perpendicular bisector part has two parts to the definition, perpendicular and bisector. You should know what perpendicular means. That is two lines that intersect at a 90-degree angle or right angle. And bisector is a segment, line, or ray that cuts another segment in half. So if you put them together, a perpendicular bisector is any segment, line, or ray, two that's, I'm not sure why there's two that's there, that cuts a segment in half and meets at a 90-degree angle. Okay, so the first page here is going to deal with perpendicular bisectors, and then a little bit into the backside. And then we're going to finish up with angle bisectors. And an angle bisector is a segment, line, or ray that cuts an angle in half. Okay? So we're going to have 4 theorems, but really 2, because 2 of them are converses. So we're going to have perpendicular bisector theorem and angle bisector theorem. The perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then that point is equidistant from the endpoints of the segment. Now that is a little confusing if you look at the words, so I'm going to break it down and we're going to do a proof to show that this actually works. Okay, so I'm going to use this picture to kind of go through what the theorem is saying. So first I'm going to talk about the picture and what's given. I'm giving you that CD is the perpendicular bisector of AB. Okay, so CD is perpendicular to AB. It also cuts AB in half. Now, going back up to the theorem, if a point is on the perpendicular bisector of a segment, well, the perpendicular bisector is CD. A point on the perpendicular bisector would be C. So C is on the perpendicular bisector of a segment. That's given. What can we conclude? That that point, C, is equal distance from the endpoints of the segment. So the endpoints of the segment would be A and B. So it's equal distance from C to A as it is from C to B, which is what we're trying to prove. We want to prove that CA and CB are the same length. So if I can prove that, I've shown that that theorem is true. So I'm going to do this really quick. I'm going to tell you, you will not have to prove anything using this, but it's good to see that the theorem works, and that's why I'm doing a proof here. Plus, it's a recap of proofs, which is good to see as well. Okay, so the given is CD is the perpendicular bisector of AB. That's given. Well, that has two parts of the definition, right? I'm going to focus on the perpendicular part. If CD is perpendicular to AB, that means angles CDA and angles CDB are right angles. That's the definition of perpendicular. Well, if they're both right angles, then they're both equal. So CDA is congruent to angle CDB because all right angles are congruent. So I'm going to go ahead and mark those. And then I'm going to use the second part of the definition, bisector. If it's a bisector, that means AD is congruent to BD because of the definition of bisect. So I'm going to mark that, AD and BD. And then I can say that CD is congruent to itself because of the reflexive property. Mark that. Now it's enough to say the two triangles are congruent. Triangle ADC is congruent to triangle BDC by side angle side. So yeah, Unit 4, this is all Unit 4 right here. Okay? And we're using it to prove a theorem, which we're using now in Unit 6. Since the triangles are congruent, I can say CA is congruent to CB because of CPCTC. And now I've just proven that theorem, which means it works. Okay? Every time. Now, this problem here is a little tricky, but it's also kind of easy at the same time. It's easy in that there's only really two choices. AD is either going to be 4 or 5. We know that. And CB is either going to be 4 or 5. So you really have a 50-50 chance on both of them. Now, if you're okay with a 50-50 chance and just guessing, go for it. But I'm going to show you a way, hopefully through these questions here, to figure out which one it is and not have to guess. Okay? Notice my question. Which segment is the one getting cut in half? So which segments am I talking about? I'm talking about CD and AB. Which of those two is getting cut in half? Well, the lines show me that it's CD. From here to C is the same as from here to D, which means CD got cut in half. We don't know that AB got cut in half. It looks like it, but we don't know it. But CD is the one getting cut in half, which means AB is the one that's doing the cutting. Which segment is the perpendicular bisector? AB. It's doing the cutting. It's the one that goes through the middle of CD. Now, how does that help me? Now I can use the theorem. Okay? The segment that's the perpendicular bisector is AB. So that means if a point, we'll call it A, is on the perpendicular bisector, it is. So A is on the perpendicular bisector. What does that mean? What can I conclude? That point, A, is equal distance from the endpoints of CD. So the endpoints of CD are C and D. So from A to C is the same as from A to D. So that means AD has to be 4. Same reasoning, B is on the perpendicular bisector, just the other side of CD. From B to C is the same as from B to D. So BC is 5. So identifying which one's getting cut in half helps me to figure out which one is the perpendicular bisector. And when I figure that out, I can use my theorem. The converse of the perpendicular bisector theorem is just the reverse of the previous theorem, which says that the previous theorem said if you have something on the perpendicular bisector, it's equidistant to the endpoints. So if a point is equidistant to the endpoints of a segment, then the point is on the perpendicular bisector. Of the segment. Okay, so find the value of x and explain how you got it. So what I see is FH is congruent to FG, which tells me F is on the perpendicular bisector of the segment. So that means FE is the perpendicular bisector of HG, which means if it's the perpendicular bisector of HG, that means it's bisected, which means HE is congruent to GE. And now I can solve for x. By the way, that's my explanation. Because the point is equidistant to the endpoints, it's on the perpendicular bisector, and therefore the two parts are congruent. So 5x minus 3 equals x plus 5. 4x equals 8, x equals 2. You can check it. 5 times 2 is 10, minus 3, 7. 2 plus 5 is 7. They're equal. Therefore, you're right. Okay, moving on. So that was all perpendicular bisector stuff. This little piece right here, very small portion of the notes, but it's a very important portion of the notes. And I'm going to take some time to explain it. But you have to understand this to understand the angle bisector theorem fully. So the distance from a point to a line. So a point to a line. Well, a lot of you probably see that there's multiple distances, right? I'm going to draw a bunch of dotted lines. That length is different than that length, which is different than that length. So which one do I use? Well, mathematicians say the distance from a point to a line is the length of the perpendicular segment from the point to the line. So it's this one. And the reason for that is because it's the shortest distance every single time. Okay, the shortest distance from the point to the line is the perpendicular segment. Okay? And the reason, I can show you that with the Pythagorean theorem. That distance right there represents a leg. That solid line right there represents the leg of any right triangle that you make here. Any of those dotted lines would be the hypotenuse. The hypotenuse is always longer than the leg, so this is the shortest distance from that point to that line. That is going to come into play in the angle bisector theorem. Okay? So the angle bisector theorem says if a point is on the bisector of an angle, then the point is equidistant to the sides of the angle. Okay? Now I want to point out what the sides of the angle are. Well, let's go through some of the questions and I'll show you that. Name the angle bisector. The angle bisector is CF or FC. It's cutting the angle in half. How do we know it's the angle bisector? The markings, right? The markings show us that that angle got cut in half. Right? So angle ACF is congruent to angle ECF by the markings, which makes it an angle bisector. Now, since F is on the bisector of the angle, now which angle is it being bisected? Angle ACE. So angle ACE, that angle is getting cut in half. Then we can say that F is equidistant to the sides of the angle. Well, the sides of the angle are CA, ray CA, and ray CE. Right? So these are the sides of the angle. And it's saying F, the distance from F to that side is the same here as it is here. Now, before I move on, I'm going to point this question out. It's a very important question. Which symbols are necessary in order to say that FB is congruent to FD? And it would be those right angle markings. And that's where this comes into play. If those right angle markings aren't there, I don't know that that's the distance from the point to the line. It might not be the shortest distance, and therefore you can't say anything about that distance. But since those right angles are there, I know that that's the distance from the point to the line, and now I can say that those two things are equal. So now it's pretty easy. 5x equals 2x plus 24. 3x equals 24. X equals 8. And then FD, that distance there is 2 times 8 is 16, plus 24 is 40. Okay? And the converse, which isn't too hard. If a point on the interior of the angle, so there could be a point out here that fits this, but we're only focusing on the ones that are inside the angle. That's what that's there for. If a point on the interior of the angle is equidistant from the sides of the angle, then the point is on the angle bisector. Okay, so how far from K is ED? So how far from the point K is ED? So ED is here. Well, that's the distance from the point to the line, which is this segment right here. Well, I know that they're equal because it says they're equal, so that's 10. So it's 10 units. Now I can say, since K is equidistant from, so K is equal distance from ED, and, that's ray ED, and ray EH, we can conclude that K is on the angle bisector of angle, this angle is getting bisected, so angle DEH. Okay. Since it's on the angle bisector, we can solve, right? We can solve and say, without knowing that, you don't really know that those are equal. They may look equal, and you'd probably be right saying that they are equal, but now you can explain that they're equal by saying, okay, since K and C, in reality, C is equidistant, so the distance from C to that line is the same as the distance from C to that line. Again, right angles are important. That means that this is the angle bisector, which means 2x equals x plus 20, and x equals 20. And then the measure of DEH, a lot of people are going to put 40. 2 times 20 is 40. But I'm asking DEH, which is the whole angle. So 40 plus 40 is 80 degrees. Okay? That may have seemed confusing, but as you go through it, you're going to realize it's really not that bad. But ask questions as you have them in class.